If you go to this question though too, this was one of the questions you got wrong, and I just want to make sure that you have some sense for what's going on with the domain and the range. So I told my students that the domain is going to be all the x values. You see, you know, remember, of course, that this graph represents an infinite number of points, and an infinite number of points are going, in this case, the x values for these points go infinitely to the left and infinitely to the right. So, so the domain, which is all the values of x that are being used in this graph, well, the values of x being used in this graph are all the way left and right. So we would say all real numbers. They're depending on the all real. Sorry about that. So in other words, all x values left and right, and one way that you look at it too is just the graph. In terms of what x values are used, we can determine that by how far to the right does the graph go. Well, it goes in the x direction to infinity to the right. It goes in the x direction to infinity on the left. You may have, if you've dealt with domains before, another way that they deal with it is they talk about it being from negative infinity to positive infinity, and then they put it in these little brackets. They call that interval notation. We don't use it in our class. You may have used it before. So in this particular graph, it's going to be all, the domain will be all real numbers. What y values are being used is a question of the range. So the y values being used, well, there's no values. If I go to -8 down here, I mean -9, there's no. It doesn't hit the graph at y at the y equals -9 part. But where the graph does use y values is once we start to get to -8. There's a point there at -7, and all the way up. So the idea is that the range, all the y values, is going to be where the graph, the lowest part of the graph, which in this case is -8, and above. So how do I write that mathematically? I would say that it's the range is all y values that are greater than -8 or equal to -8. So that would be my range for that. Now, in the questions you got wrong, they were talking about the range of the parent function. So let me see the domain. Let's see if you got the. Okay, so the parent function, the domain and the range would look like this. The parent function, remember, for the absolute value graph is going to be something like this. And again, as you see in the x direction, it goes all the way left and all the way right. So you're going to talk about all real numbers. And that's going to be our domain. And the range, well, what y values are being used? Well, certainly -1 is not being used, -2 is not being used, but when we get to 0, the graph, you know, we get the bottom of the graph. So 0 would be one part of the range, and certainly any number above 0. So the range in this case will be all values of y that are greater than or equal to 0. So I just want to give you a sense for the domain and the range. They didn't talk too much about it in the book, and so I just want to give you a little bit of an introduction to it just to give you a sense for that. So anyway, I hope things are going all right. I'm very impressed by the work you've done already, and hopefully you're feeling like you're getting you know, at least you're in a good place with math. One other thing too is we just started today was the assignment on application of linear functions, and I posted a homework assignment that says, it's a small one for tonight, is it says 1.3, and in parentheses it says, and some review questions. So you might want to go ahead and take a look at that section 1.3 in the book and see if you can't make some sense of it. We're a little ahead of the other class, so that's a good thing. That's a good thing for you to know. So anyway, let me send this off to you, and hopefully things are going well. I'm wondering if I can video me. I don't know if it's going to work here. Oop, there it is. This is your classroom. This is going to be your classroom. I'm kind of an astronomer person, so you see the telescope in the back. That's because of me. And lots of whiteboard space. And I'm going to go ahead and turn this toward me and see if there we are. Anyway, Arnold, I can't wait to see you. Hang in there. I know you must be frustrated as heck, but it looks like you're a basketball player, so maybe you need to play a few games and get that stress out. But we'll hopefully see you soon. You take care of yourself and keep in touch. Hi, Arnold. This is Mr. Scheidegger. Really quickly, I need to apologize for the question number 7. In fact, I didn't give this one to my students because there was a subtlety in it that I really didn't want to deal with, and I didn't want to confuse them. But I'll just show you what was going on. Is that the idea was that we have a downward movement, a translation downward of 3. So the idea is that we take this, we take the linear parent function, and we're going to subtract 3 to drop it down by 3, and then they said followed by a vertical shrink by a factor of 1/3. So what they're looking at is that here we have the function x minus 3, but now we're going to shrink the entire function. So this is how they get the 1/3 x minus 1. But I'm going to ask you something. I'm going to tell you that you do not need to worry about that kind of a subtlety. Typically, we're going to be talking about the shrink in different terms that would be more understandable. Your answer is what 99% of my students would have wrote anyway, because the question wasn't really. The question is asking for the shrink to happen after the downward movement. So ultimately, this is what you end up with. But please allow me to forgive you on that question, because you're not going to be asked a question like that even on a test.